Okay, so another quick recap for the second part of this week would be quantum mechanics. We're beginning it. I think you'll notice that this week's worksheet is way shorter than last week's, but it is a weird concept. Quantum mechanics even sounds complicated. We won't be getting anywhere near as deep as it goes. It is a very, very deep concept, but we will be touching the basics of it. And basically what you will be learning how to do for the basics of quantum mechanics is tell me where the electrons are. That's what quantum mechanics is. It's just telling me where the electrons are. Where is their location in the atom? And you really can tell that from a periodic table. And I'll show you how I have mine labeled in a second. I sent you one that is labeled in your resources, and there's also one embedded in your worksheet that you can just quickly reference. If you can't make your own because you don't have yours, you're just at school, I embedded a picture into your worksheet. Okay. So the beginning of quantum mechanics. This is a really crappy drawing, but it shows you kind of what we're talking about. Basically, there are 4 different shapes of orbitals, is what we're going to call them, shapes of orbitals of where electrons can be. The first shape is called S, and it is the shape of a sphere, so sphere for S. The next is the P shape, which is I say peanut. It looks kind of like a peanut, and that's what these are. Now, the peanut shape, or the p orbital, comes in 3 different ways. In the x plane, the y plane, and the z plane, coming out at you, okay? So it comes in 3 different ways to turn the peanut, so it has 3 different orbitals. Next is d. So d is called, or stands, for me it stands for, double peanut. Now, the double peanut comes in 5 different ways you can turn it. As you can see, it was really confused. I mean, like, it already got crazy to draw 3 P's. If I was to draw 5 double peanuts, like, you wouldn't even be able to tell what I was drawing anymore. So it's really not drawable, but that's what it is. It's 5 different ways you can turn a double peanut around the nucleus of an atom, okay? Lastly is the F shape. I just drew scribbles there because F to me stands for fancy. It is so fancy that I cannot draw it. And it comes in 7 different ways you can turn that fancy shape, and each of those 7 can hold 2 electrons. So going back up, each of these things that I've talked about can hold 2 electrons each. So there's only one S sphere, 2 electrons. There are 3 ways to draw the P, 2, 4, 6, so it can hold 6 electrons. D I didn't write, but it has 5 ways to turn it. 5 times 2 in each one is 10. F, I said, has 7 ways to turn it. 2 in each one. 7 times 2 is 14. So we really only are going to get to this F shape like hardly ever in this class, but it's for the really big atoms. Okay, now if none of that made sense, that's fine. I'm going to show you little easier ways that you can just answer your worksheet. I'm not expecting you to fully understand quantum mechanics, just to start getting the basics. That's all we expect at 10th grade level chem. All right, so this is the periodic table that I've broken down. You'll have one very similar in your worksheet and one I gave you. This is the S block right here. See, it is labeled with a S block. 1S, 2S, 3S, 4S, 5S, and you'll see where that comes into play in a second, but they're labeled. It's labeled in the one I gave you, or you could label your own like mine. Then we hop over. So basically you trace your finger. I have 1S here, and I'm just gonna go over here, and I don't hit anything. So I have to go back. So then the next level, so I was in the nucleus, the first thing outside the nucleus would be a 1S subshell, be a sphere. The next thing would be 2S. So it'd be like a sphere and then a sphere, a bigger sphere. 1S, 2S. Then I would trace my finger and I'd hit a P subshell. So finally you're in P's, and there, if you notice, there was a 1S, there is not a 1P. Doesn't exist. There's a level 2P. Now, when I'm getting into that, the number levels, 1S, 2S, 3S, 2P, 3P, 4P, 5D, 4F, what are those numbers? Those numbers are called energy levels. All an energy level is how far away it is from the nucleus. We're saying this is my nucleus, my protons and neutrons are in here. Where are the electrons? Well, they're outside in the cloud, right? So every time you go up an energy level, it's slightly further away from the nucleus. So if I say that here's my nucleus and I have a 1s subshell, well, it's really close to the nucleus. It's just right here, 1s in a circle. If it's in a 3p, well, then it's level 1, level 2, level 3 away, level 4, level 5, level 6. So energy levels is just distance from the nucleus of how far away that electron is, okay? Again, if it's still sounding like a bunch of gibberish, I'm going to show you how to at least answer your questions, okay? So now we're going into the problems. First question said, how many energy levels does oxygen have? So how do I know that? So to answer how many energy levels does something have is you just find the element. So let's find oxygen. Oxygen is here. What number is it on? 2p. So the number is 2. So what energy level is it on? 2. Okay, so the answer is 2. Now, how many sublevels does an energy level have? So a sublevel, how many sublevels does something have is what energy level it's on. So let's say it's energy level 3. So how many sublevels does energy level 3 have? Okay, well, energy level 3 has a 3s, has a 3p, and it has, well, that's a 3d, I mean, has a 3d and has a 3p right here, okay? So it has a 3s, a 3d, and a 3p. 3. So whatever number energy level you're on, that's how many sublevels it has. So energy level 3 has 3 sublevels. Energy level 4 has 4 sublevels. 4s, 4d, 4p, and it has a 4f. 4p, 4d, 4s. What have I not said? 4s, 4p, 4d, 4f. So it has 4. Energy level 4 has 4 sublevels. So you literally just write the number. So if something says how many sublevels does that energy level have, well, what number energy level is it? It's 3. Okay, then it has 3 sublevels. Which sublevel does not exist? So this, you literally just look at the labeled periodic table I gave you. Which one's on it? Which one's not? So as you see on mine, I have 1s or 2f. Well, 1s is there. It's labeled. 1s, have it. The other one was 2f. Do I have a 2f? Well, the f block is down here. This is the f block. There's a 4f and a 5f. So is there a 2f? No. So that doesn't exist. So 1s exists. 2f doesn't. So how to answer that? Look at your periodic table that I gave you in your worksheet and just see which ones exist, which ones don't. Give the number of orbitals in the sublevel. So give the number of orbitals in the sublevel. If you have it memorized, it's easy. Or if you have your notes out, it's easy. Give the number of orbitals in the sublevels. S always has 1 orbital, 1 sphere. P always has 3 peanut shapes, and the X and the Y and the Z plane. The D, which is too confusing to draw in that way, has 5 different orbitals, has 5 different ways you can turn that shape around the nucleus, 5 different ways. F, remember, it's so fancy I can't even begin to draw it, has 7 different orbitals, 7 different ways to turn around the nucleus. So S's have 1, P's have 3, D's have 5, F's have 7. So you just look at that little symbol. This is an S, well, S's always have 1. So the answer is 1. If it said a 6D, then it'd be 5, because it always has 5. D's always have 5 orbitals. Okay? Almost done. 2 more questions. Give the number of electrons in sublevels 2s and 3d. So give the number of electrons. Same thing. It's just like memorizing it or having your notes out. S's are a sphere with 1 orbital. Well, every orbital holds 2 electrons. So if there's only 1 orbital and every orbital holds 2, then it can hold 2 electrons. So every time you see an S, it can hold 2 electrons. P's have 3 orbitals, 2 in each one. So that would mean 2, 4, 6. It can hold 6 electrons. Every time you have a P subshell, it can hold 6 electrons. D has 5 orbitals, 2, 4, 6, 8, 10. So it can hold 10 electrons. Every D subshell can hold 10. And 7, no, I meant to put an F there, darn it. I'll change it. It's an F. So F's have 7 orbitals, 7 ways to turn around the nucleus. So now I need more hands. 2, 4, 6, 8, 10, 12, 14. How holds 14 electrons, okay? So it's 2, 6, 10, 14. Now, if you can't memorize it, oh, you get to use your notes. You're at home. Use your notes. In order for electrons to coexist in the same orbital. So this is just a question at the bottom. So if you're watching this video, this is the answer. How can electrons fit in the same orbital? So if every sphere, sublevel S, can hold 2 electrons, how do those electrons coexist with each other? They just have to be going different directions or have opposite spins. Because again, electrons are both negative. They don't want to be near each other. They would repel. So how can they coexist together in the same orbital? They have different spins. That's it. Opposite spins is the answer. Okay? Hope that helps when y'all are answering this worksheet. I literally walked you through every single one, and some of them were even answers to it. So watch it as you do the video, and hopefully it helps. All right. Have a good day.